Hi, everybody. So how are you feeling about the day so far? All right. Well, we have one talk left this evening, and it's a good one. So Apple and Santiago both work at Google on some of our IS applications, and they're going to talk about building a flexible and extensible framework around Selenium, and I am really looking forward to this one.
Okay. Thanks, Alan. So welcome to the last talk of today. Today we can talk about how to build a flexible and extensible framework around Selenium. We want to use our experience as an example on how people can build such a framework, so that also for those of you who's getting started with Selenium and building test frameworks, hopefully this will give you some new ideas on how to kickstart your project. Our framework's name is Ringo. As you might have guessed, most of our team members are fans of the Beatles, and that's also where our motto came from. Our motto is getting better all the time. So let's kickstart. So this is the outline of today's presentation. First, I'm going to talk about the challenges that we face in testing web applications, and then I'm going to talk about how our design decisions address those challenges and thus enable us to meet our goals. And then we're going to talk about the framework architecture as well as the framework's features. And we'll conclude today's presentation by going over how Ringo has helped us in dealing with issues that have come up along the way. And at the end, there'll be a Q&A session. So first, in the world of testing web applications, we face many challenges. For example, we are working with agile projects, which means they have frequent requirement changes and frequent releases, which means that on one hand, we have to deal with the frequent release cycles, running the regression tests, and on the other hand, we have to keep up with adding tests for the new features that's coming out every week. Another challenge that we face is that we're dealing with complex web applications, and so there's a lot of AJAX and dynamic HTML in our applications. And it's from the user's point of view, those technologies makes the applications more usable and interactive. But from the testing point of view, it's actually making it harder to test because of the asynchronous nature of those technologies. And also we're dealing with limited resources working on multiple browsers and platforms. I guess all of you have similar stories. So in order to deal with those challenges, we came up with a few design principles. First, we decided to pull together our resources from some of the projects we have to build a common framework so that we can reuse the same framework across the different projects, thus saving us time and resources, and we can come up with a better solution. And as for the design principles, the first and foremost is simplicity. So we want to isolate anything that's not test case specific from the test case, so that the test case can be more resilient to application changes. And in order to do that, we are taking the following actions. First, we are isolating all the application-specific logic into an ApplicationClient class. And again, from the past projects, one observation that we made is that a lot of times when you fill forms or when you interact with tables, a lot of times you end up writing really specific and unreusable code. So we want to be able to abstract that out and have the framework provide utilities for you to filling forms, for you to reading from or writing to tables. And also one other challenge in testing is that not knowing an action has completed, especially when it comes to AJAX applications. And hard-coded sleeps are error-prone, and it not only pollutes your code, but it's error-prone, and because it can fail due to external factors such as the machine speed, congested network, or the machine's overloaded and things like that. So we want to also be able to provide utilities for dealing with those timing conditions by the framework, so that the test case writer doesn't have to deal with those timing conditions. And another thing that we found from past experience is that a lot of times when you interact with specific UI objects, you're required to use specific methods. For example, like interacting with a link, you say click, and like when you type in a text, you say type. So we want to be able to provide a uniform way of accessing those UI elements, and that also is the foundation for many other features of our framework. As for flexibility, we want to be able to provide the test case user like the ability to group the test cases into whichever way that makes sense to them, and be able to control what tests to run during runtime. And we also provide placeholders for end users to provide dynamic configuration data or just data for their test case. And we also know that we want to have the features as generic as possible, but on the other hand, we know that today's web application, you're no longer dealing with like a simple HTML element, because I mean, think Google Maps, think those iGo, think those drag and drop advanced controls. So we want to also provide the end user's ability to extend and customize the interaction with the particular UI object that they have for the application into whichever way that they want to customize it in, because we don't know what are the possibilities. And as for maintainability, we want to be able to externalize anything that changes often into external files. And also, one other thing that we learned from past frameworks is that the data tend to scatter across the different test cases. And then it gets larger and larger, and you don't even know what kind of data you're using for the different test cases anymore. And it gets harder to maintain because there's a lot of redundancy of data. And so when something changes, it's not really easy to make changes because it's all scattered out. So we want to be able to take that into consideration and eliminate the data duplication issue. One other design consideration we have is that we want to support data-driven tests by provide ability to run the same tests with different sets of data, so that to take full advantage of automation, and so you can run the different permutations. And also we provide a data generator for the end users to be able to substitute in dynamically generated but structured data, like an email address or like a phone number, those kind of structured data, to their test case as well. We want to be able to leverage third-party tools to provide important functionality so that we can, say, focus on building abstraction layers and customize it to, and then also integrate the different pieces together to fill our needs. And there's a couple of requirements or desirements that we have when it comes to the tool selection criteria. First, we want to be able to handle all those advanced AJAX controls or dynamic HTML JavaScript on our web pages. Another thing that we consider is that we are working with mostly J2E web applications. So it would be nice if we can use the same technology or language technology or tools as the developers, because that will allow for tighter collaboration among the two groups. So that's why we picked Selenium. For those of you who don't know, it's an open source web testing tool that uses JavaScript basically to control the web application that you're testing. So highlighted here are some of the features that we like a lot, and also are the foundations of other pieces that's making use of by the framework heavily. For example, there's a concept of locators. So this is a way for Selenium to identify an element on a UI page, and it supports different locator strategies, as I shown here. So you can identify an element by name, ID, DOM, XPath, etc. So it's very flexible to identify any element on the page. Another feature that we really like a lot is the wait for condition. So as shown in the example here, so we run into a case where when the page first loaded, a button is disabled, and then after a few seconds, it becomes enabled. And so wait for condition is great in this case because it takes a JavaScript expression and a timeout, and it'll run this, evaluate this JavaScript expression in a loop until it's evaluated to true or until it times out. So that it's definitely more reliable than hard-coded sleeps. And another feature that we like is the get eval. It's basically something that we can use to evaluate JavaScript, whether you want to extend the Selenium functionality by providing your own JavaScript function using the user extension, or just by invoking JavaScript functions from the web application you're testing. This can be really useful. As for the testing framework, we're using TestNG. Basically, it's a JUnit-like framework, except that it supports more flexible annotations. But the single feature that really stands out about TestNG is the data providers feature. This is something that we make use heavily to support for data-driven testing. So what it does is that basically you can define it to return either an iterator object or a two-dimensional object array. In this example, I'm showing it to return the two-dimensional object array. So each row in the two-dimensional object array represents one call to the test method that you define there. And the second parameter, the number of columns, is mapped to the different parameters for your test method. So underneath the cover, test engine will handle, looping with the different rows inside your data provider and then invoking the method with the different data that you provide. So this is very powerful because you can define the data provider to be any way you like. I mean, the logic is up to you how to define it. You can read from XML file, you can read from a database, or you can use your data generator to provide those dynamic values. Another tool that we are using is Firebug. We are using it as a development tool. So it's a Firefox extension where people normally use for inspecting UI elements on a page. So the way that we use it is we kind of piggyback on top of that because we found one time-consuming activity in web automation is actually to be able to find out the different locators of the different UI objects on the page. And so we piggyback on top of that to generate the UI configuration file automatically for us. So that saves us a lot of time. And so you can see the screenshot there, and UI map is the extension that we added to there. So this is the framework architecture. The top layer you can see is the configuration layer. So it consists of 3 objects. So the application config, the UI map, and the data map. And the second layer is the heart of Ringo because it contains a lot of our UI object abstractions. It contains our Selenium wrapper, as well as utilities and our data provider class. And the 2 green area are the 2 entry points to our system. So how an end user will use it is they'll extend the base client and base test. So for the application client, is something that contains a high-level method that you use for interact with your application, and that will extend from our base client. So we can make use of our Selenium helper and all those configuration objects that we have. And for the base test, you can, you implement our you extend our base test to provide your application-specific tests. So the point I want to emphasize here is that the application test class will make use of the application client. So that doing so greatly simplifies the, writing a test case because a lot of your important logic will be located in your application client class. So that makes the test case simpler to write. So moving on, this is the application config file that we have. So it's something that you can use to, because you write down all the different parameter, name, value, pairs, global configuration parameters for your application. So in this case, I mean, you can use any arbitrary name value pairs because we're just using like a hash to parse this. And the bolded area are the reference to the UI map and the data map. So it pretty much holds everything together. And so here you can see the other global parameters such as a global timeout that we define here, like 5 minutes, and the URL and things like that. So you can use this to define the different test environments that you're testing against. So UI object, what's an UI object? Basically, it's our abstraction for the UI element on a web page, and it contains the read and write interface. So read is for reading, like extracting information from it, and then write is for interacting with it. So for example, in this example, I'm showing a text field UI object. So the read will be calling get text, and then write will be type. And then if, on the other hand, if we talk about link, the read will be, again, getting the text from the link, and write will be clicking on it, and vice versa. So having this uniform way of accessing UI objects, it's very powerful because if the UI object changes, then, if the UI object type changes, maybe your test code doesn't have to change because you have this level of abstraction. And our framework provides all the default implementations for the common UI objects. And then you can also extend your own, and then I think Santiago will go into that later. And so having this also provides the foundations for some other features we have in the framework. So UI map is something that we use to centralize the location of UI elements on a page. It can contain, it contains 1 or more pages, and each page can contain pages inside, so you can have embedded pages. And a page doesn't really have to be like a literal page, a web page. Think of it as like a container. It's like a grouping of the UI elements that you're dealing with. So if you have a form in a page, maybe you want to consider that a page object. or if you have different sections, you may consider them different pages because they may load at different times and things like that. And so inside, you can see that it contains a list of UI elements, and each UI object has a name, which is a symbolic alias that we are making use of inside the framework. And then there's a type indicating what type of UI object it is, as well as a locator, which is what Selenium uses for interacting with it. As for the data, we think of it as two different groups. So a lot of times, the way that people use test data, usually you have like a default set of data profiles that's shared amongst your test case. And then your test case may want to reference to those and then overwrite one or two properties, or and then to test for a particular corner case for your test case. So that's how we model it in our data map. So here in the top section, you have the different, so you can categorize your global data into different categories. And then at the bottom, you can see an example of a test case kind of referencing to the common data using the name, and then it overwrites one of the properties. So this is actually a small example, but think of like a really big form, like a user sign-up form that contains a lot of data. Using it this way greatly reduces data redundancy, because then you can define your common data in one place and have your data test case specific data point to that and overwrite only the parameters that you need to change. And also have this in one place kind of give you visibility as to what kind of data you're using, because you don't want to be using random data that doesn't really add value for your test case. And one common action for web testing is filling forms, right? So a lot of times what you do is, so we make the observation of, like, it doesn't matter which forms you're talking about, you can kind of abstract out that there's a commonality amongst them. So basically what you're doing is that you are looking at all the UI elements inside a form and kind of looping through them and then filling out the values one by one, right? And so that's why we abstract out this thing into our helper class, and we have a field form method. So basically what it does is that it takes a page object and a data object. And then for each of the UI objects that you define in the page, it find out the data objects, the corresponding data value to be filled in, and then it just fills each of the UI elements. It just calls write of each UI object that we have. So again, having it like this is makes the test case a lot more maintainable and simple to write, because you may just use field form and passing in your page object and your data object. And then if something changes, probably all you need to do is update your UI map and your data map, and your test case doesn't really have to worry about it because it's all handled underneath the cover. So this is a picture of our application client class. So like I mentioned earlier, this you define all your high-level application APIs in this class. And underneath it, you use our Selenium wrapper to interact with the web application that you're testing. And since a lot of the logic is located here, it simplifies the logic of your test case and also makes it easier to maintain. And another point I want to make here is that, I mean, the application client doesn't really mean that you can only have one class. It's actually a subtree of classes if your application gets more complex. I mean, you can have a client that have different page objects or component objects, and then have the client kind of delegate the actions to the different components if needed. So this is our application test object. So what it does is it contains test cases that you define in the test case repository, and then it makes use of the high-level APIs provided by the client class. And same thing, similar to the client class. Again, here it doesn't mean that you can have one test class. Again, you can have like a global application test class that you define common setup teardown or data providers or common utility methods for your test case to reuse, and you can have, like each feature can have their specific test case that can extend from this one, so it can have its own subtree here. So this is a common scenario for like a test case flow for the Google search test. So here you can see that it just makes a call to the client search method passing in the data. And then underneath it, it calls a field form. and then the data comes back, and then it just asserts on the data. So you can see that writing a test case is actually pretty simple, because a lot of the logic is either handled by the framework or is handled by the client class. And this shows the client and the test class side by side. And so this is, again, an example for Google Search client. Because we're testing with internal applications, we can't really show you examples using those, so we're just using some common Google applications as examples here. And again, you can see that the client class will contain high-level APIs such as basic search and advanced search. And then for your Google Search test class, it will call the client's APIs. And another point I want to make here is that sometimes you have a test case that you are testing different applications or integration of different applications. And having this design is also flexible in that way, because your test case can use multiple clients. And so that's one way that we find it really useful, because we have multiple projects all kind of use this approach, and the test case can kind of talk to the different client application classes. So now I'm going to hand this over to Santiago, who's going to talk about the more advanced features of our framework.
Okay. Hi, everyone. So as Abel was saying, I'm going to go through into a little more detail in some of the features of the framework. I'll talk about some Ajax handling utilities to deal with some common problems in Ajax applications, custom UI objects and decorators to allow extending the framework for particular needs, a class that we created with a lot of helper functions to deal with tables, which are usually along all applications, and placeholders to allow dynamic configurations, the data generator tool that creates random data in runtime using structured data like emails, phone numbers, zip codes, and database support. It's just basically a JDBC wrapper to allow queries into the database and navigating the results in case the test case requires some verifications against a database. So as working with Ajax, one of the hardest problems is with asynchronous stuff. And so as Vivek was saying today, waits are ugly, wait for a condition are also ugly, but they allow a lot of more flexibility. And what we did in this case was extracted it from the test case writer. So the test case writer doesn't need to worry about that. What we did is we have this tag that can be placed into page elements. That is the loaded condition tag. And there you basically type your JavaScript condition to test for true using Selenium's wait for condition method. So imagine, as a hypothetical example, the iGoogle homepage, which has all these gadgets that loads and separate at its own time individually of each other. And if we wanted to test just the search part, we don't need to wait for all the gadgets to be there in order to start testing the search. We just need the search text box and the search button, and that's all. That's it. We don't have to wait for all the page to finish loading. And in this case, what we do is we create a page tag in our UI map, which represents the search form. And this page will have a loaded condition that will check for, in this case, for the query text box and the search button to be there. And then we can, in our code, just call our own wait for page to load, which actually is our own implementation that uses this loaded condition of the page you specify, and it will wait until that condition is true in order to continue. A useful thing of this is that since we have pages defining sections of the whole page, we can have nested pages, and each page might have its own loaded condition. For instance, again, in the iGoogle search page, every gadget there might have its own loaded condition, which tells when it's finished loading. And so if we wanted to wait for the whole page, we can call this method to wait for the container page, and it will retrieve all the loaded conditions of the inner pages and combine them and wait for all to be true in order to go on. This was pretty handy, but we still had this wait for something there, and we didn't want to keep writing tests saying, okay, click here, then wait there, then click there. So we tried to simplify this by adding this reload trigger attribute to our UI objects. Basically, not every, but many interactions with the application causes a page to be loaded or another section of the page to change. And we need to wait for that in order to continue with our tests. Like as a simple example here, the next button in search results page in Google. If you click on it, it will reload the page with the results for the next page. And we want to specify that if we click in that link, we want to wait until that page is loaded to continue testing. So combining this with the loaded condition, we just specify a page name as a reload trigger attribute. So the framework will automatically look for that page that's identified in the reload trigger, and it will look for its loaded condition, and wait for that condition to be true in order to go on with the test. This is useful not only for a whole page reloading, but also when changing a value in a combo box or something may trigger the reloading of an iframe or a div or a section of the page that is identified by a page element with its own loaded condition. So you just declare this loaded condition and the reload trigger pointing to that page, and so the framework will wait until that section is loaded before continuing. And by doing this, we abstracted all this logic for the test case writer point of view. So a test will be just click on the next item and do whatever you want to do next, and all the waiting is hidden from the test case writer. And also it encourages the reuse of code because we don't want to be specifying everywhere that we interact with with the same button or with the same link that we have to wait. So we just specify it once, and we click the link, click the button, and go forward. So we provide, the framework provides a lot of classes to handle regular elements in the UI, like text boxes, buttons, images, links. But many times the application defines their own kind of UI controls that are actually AJAX stuff or just a different behavior of regular control. And so one of the features we added to the framework was the ability to create our own UI objects wrappers or UI objects classes. So imagine in this example, we have the Google Suggest page, which you start typing a search, and it will drop a list where you can pick an element from the list of other search similar to the one you're searching. So if for some reason we wanted to test this element and we required that this element had a specific interaction that required us to wait after each character type, so we couldn't use a regular text box to model this UI object. So we define our own suggest text box in this case, and this text box, this UI object will type the text into the text box one letter at a time and waiting for the specific time. This is, again, just an example. It doesn't make real sense in real life. It's a way of extending the framework for fitting your own needs. And another interesting issue here is that you can add your own methods to the UI objects. You implement the UI object interface or extend the abstract UI object class, but you can also implement your own methods. Like for this UI object, we could have a method like select first item from list or select the nth item from list. And that way we keep a uniform way of interacting with our elements, but we can also add new functionality to interact with complex elements. UI object decorators. This is a feature I really like. It's for the cases where we need to add some behavior to a specific element or a specific interaction with an element. And it's another way of extending the regular UI objects. So imagine we have an example here that there's a text box where you type a credit card number, and once you move to the next control, it will select the type of the credit card from the list of types of credit cards there. The thing is, if you use a regular text box to just write our credit card number in there, it won't trigger the blur event, which is what actually triggers the algorithm that detects the type of the credit card. So What we can do in this case is add this decorator, which is just an implementation of the decorator pattern, which consists of wrapping an object with another object, which implements the same interface to the outside in order to make it transparent, and add behavior to the original object that's being wrapped. So for this case, for instance, we created this blur decorator that it simply calls the right method of the UI object that is wrapping, and then it triggers the blur event. The great thing about this is that it's reusable. Any other element that we need to trigger the blur event, for instance, in this case, we can add the decorator to the definition in the UI map, and that will be handled completely transparent to this case, writer point of view. And another great thing is that we can chain decorators and wrap one on top of the other to keep adding behavior to the standard UI object that we're wrapping. And for instance, Ringo already provides some decorators like wait for element decorator that will wait until the element is present before typing or reading or whatever interaction it's required. An element present decorator for verifying that the element is there before reading from it or writing into it and returning null in case it's not there. So it's another way of extending behavior and helping avoid the duplication of code, because again, we have this in a declarative way in the UI map, and it's reused along all the tests that uses the same objects. So tables are something that are all over applications which handle data usually, and are usually complex to handle because they're not always HTML tables as we see them. Tables might have layout, rows added there just for making things look nice, and they're kind of complicated to handle sometimes. So we created a class to abstract some of these functionalities. We call it table objects. We have something we're calling our objects object. So what we did here is we modeled this as another page, as if it was a page, using a UI object for its cell of a given row. So we use a placeholder in our locator definitions that will be automatically handled by the framework that will iterate through all the rows. And we define every cell is the UI object, so any behavior that can be abstracted in a UI object can be abstracted into any cell of a table. And then we provide some methods to, for instance, accessing cells by row number and column number, by reading a whole row as a map of column name value, or accessing a row as with a column name and row number, which might be really useful for tables that can change the order of the columns. We can read or write from cells in case we have tables that had drop-down lists or checkboxes that we need to click. And there are other features that the table object provides, like verifying that a value is present in all the cells of a given column, retrieving a whole column. And also there are other configuration items we can specify, like if the data doesn't start at the first row of the table, if the data doesn't end at the last row of the table, if there are rows in between the actual data rows that needs to be skipped, we can specify a lot of other parameters in order to make it easy to handle. So from the test case writer point of view, it's just a table object with data in there that you can access as if it was a simple table. And since we are using UI objects to model all the cells, it doesn't really need to be an HTML table. If it is displayed as a table and as a list of rows or something that can be modeled as a table, we can handle this by abstracting everything as UI objects and locators. And anything that can be identified by locators can be considered a cell of the table. And if we can iterate through them, then we can read it as a table. So the last feature I'm going to talk about is placeholders. This is just a way for having a more flexible configuration files. We can have placeholders both in application config, general application configuration files, as well as in our data maps or UI maps. So we can, the framework already defines some standard placeholders, like if the placeholder start with the env prefix, it will read an environment variable and replace the placeholder with that variable. If it starts with a sys prefix, it will be a system variable passed to the JVM. You can create any placeholders you want, and then in runtime tell the framework to replace a given placeholder with a given value. You can also, there are timestamp standard placeholders, and we can make use of the data generator tool through the placeholders, which is very useful when you have to create dynamic data for, I don't know, creating an element of the whatever application you're testing. So for instance, the data generator can create strings of a given length with random characters, email addresses, phone numbers, zip codes, any other pattern that you can specify in a regular expression. And as for providing extensibility, you can define your own placeholder handler classes. If you want to create your own placeholder to replace it with a value extracted from whenever you want, for whatever you want, you just create your own placeholder handler class and can use that for your configuration files. So, summing up a little bit, how is the automation process using the Ringo framework? Basically, what we do when we write our test cases is we first define the application configuration, like the URL of the application, the browsers we're going to test in, the platforms, and any other general parameters. We define that in our application config file. Then we create what we call the UI map, which is this collection of pages with UI objects inside. We actually have, as Apple was mentioning, this Firebug extension that allows us to go through the page, clicking in the elements, and then create at least a skeleton of the UI map, and then we can extend it by hand if we need to. Having the UI map, we can create the client class, which is, as Apple was stating today, as the class that actually interacts with the application and providing to the test case writer an API of something much higher level, like perform search in the Google search example. Then we define data that we usually try to separate it in a common set of data that can be reused across many tests. And then for specific tests, we override that data if we need to, or we declare our own specific data for our test case. And finally, we just implement our test cases, which are simple test-ng classes annotated with test-ng annotations and the data providers that will do simple actions defined by the client and retrieve results and verify that the results are what are expected. So the test case pretty much looks like the specification. If there was a test case specification or a description of test case, when you see the test case, it just looks like that. It's like perform a search, get the results, verify that the results are correct. It's much simpler to write. And we have common actions abstracted inside our client classes, so we can reuse them across test cases. So I'm going to go to just a small set of examples of how Ringo was useful for us. One of the things that more commonly happens is changes in the UI. There are many types of changes. Here I'm illustrating just a small example of a case we had. We had this text box to enter a country name, and in one release it was changed to use a drop-down list to select the country name from the list. And all we had to do to have our test working was just change the UI object declaration and change it from being a text object to being a select object. And the client class didn't have to change anything. The test case class didn't have to change at all. And there were more than one test cases that were using this control, and they were all affected with the change, but they were all solved by just changing the XML file. Another case was a case when we had to implement our own UI object to handle, in this case, this multiple selection list. We had two constraints in this case. We didn't know the values from beforehand, so the values were generated by the applications, and we needed to select a given number of items randomly. So we created our own random multiple selection UI object, which actually extends the regular select UI object. And what we do is in the write method, we pass in the number of items to select, and it will retrieve all the possible options and randomly select that number of options. So again, this was a case where we needed to extend the core functionality of our framework, and it was handy because we used this control in many test cases and in more than one section of the application. So we just needed to implement this once, and then we could reuse it everywhere we needed to. And another case I'm going to show to finish today is a case where the application started to handle I-18N data. So we needed to test it with different character sets. And all we had to do was, in those test cases that needed to be tested for I-18N, we just added a new test set with the data corresponding to that country. For instance, for that character set, like we added data for Chinese or Japanese, Latin accented characters. And the test case will run now once per each data set. So all we had to do was add the new data as a new data sets in our data maps, and the test didn't have to change at all. The same test was run with different character sets. So before finishing, I would like to mention the whole team that's been working with us. This is just 2 of us today, but the team is a whole bunch of people working behind the framework. And so I'd like to give some special thanks to Albert Chen, Alejandro Bologna, Ariel Rodriguez, Nicolas Frontini, Raul Bajales, and Andrew Salamatov, which not only are part of the framework, but also helped us a lot with the presentation. So if there are any questions, just shoot.
Apple, you talked a little bit about Firebug with UI map extension. Can you just explain a little bit how that relates to your XML files?
Because like I said, we externalize all those UI elements in the UI map, right? And then we find it actually it's really time consuming to manually write those HTML tags for the different UI elements for the locators and things like that. And if you don't have that extension, you would have just, like look at XPather or some other extension to find out the locator of the UI elements, and then you'll be manually writing them inside the UI map. So that's time consuming. So that's why we kind of piggyback on top of Firebug, so that we can just click on the button and then it just generates, the UI objects and the locators for us automatically. And then we just need to maybe, customize on the names and things like that if we need to.
So you're using the UI map to generate the XML config file.
To generate the UI map XML.
Exactly.
Mm-hmm.
I had a couple of questions. Is the UI map generator in Firebug a custom extension to Firebug that you have written?
Yeah, we added an extra tab on there.
Is that something that you can share?
I think we are working on that.
We're thinking about it, actually.
We're thinking about
I have a
It's just
couple.
that we have to make a couple changes to our framework and things, and then, but stay tuned on the testing blog for information. So.
Sure, that'd be great. A couple other questions. What are the advantages of keeping a page map in XML as opposed to encoding those attributes directly in the client class?
I would say the most important advantage is reusability and having all the configuration in one place. So whenever we have to interact with the element, we pick the configuration from there, and we don't have to write the same stuff all over the...
And also keep in mind that because we're using XML file, so it doesn't have to, not like all the pages have to be in one XML file. You can use like includes or entities to spread them across, maybe using a different XML for each of the tab on your application and things like that. So having this is just more organized. It's easier to change things. When something changes, it's easy to find things and change them. And then it's all in a central place. Mm-hmm.
Do you ever have to drop down and parse the raw HTML that's on the screen?
No, for reading that...
for anything complex that you can't get Selenium to do naturally?
We usually, if we have something that Selenium cannot solve by itself, we usually use JavaScript, and we call the JavaScript with getEval and get the value that way.
Do you have any problems with XPaths being slow on IE, and what do you do about it?
Yeah, that's a common problem. So
Yeah.
we try to talk to developers and convince them into giving us IDs or names, yeah, and things like that. And then even sometimes they cannot give us IDs or names. We, at least they give us something, at least like ID at the table level. So if we need to access a cell, at least the XPath is kind of short or something like that. So
Very cool framework. Very nice.
thank you.
Thank you.
Hello.
Yes.
I do have actually 3 questions.
Okay.
Again, the first one is in the workflow that you showed of how to execute a test. Somewhere at the end there was, and then we do some asserts on the data. I think that is usually one of the most difficult parts, and also one of the parts that tends to break when it shouldn't break. Is there any further support in your framework for these assertions on the data?
I think it's just mostly in a data map that
Yeah.
sometimes you can define what to verify against the data. You can, because you can pass different properties. You define multiple data values, and the data can contain multiple properties, so you can easily define them and have it all in a central place again. And
Yeah, usually the input data for the test case is the input data for the application and the verification data.
Usually it's the same, but then again, in the way that we structure the data map, you can also overwrite, something if it turns, once it gets stored, it shows something different. But you can, again, using the placeholder or whatever to overwrite, just point to that and say, overwrite this property, I'm expecting a particular value, and you can also do that.
The other thing that I think I did notice is that some of your XML descriptions actually look pretty much like they would contain some Java code somewhere deep inside. Especially the one you showed with the HX example and the wait on load, where you had if this, it looked like Java objects and method calls. Isn't there kind of a danger that people start to abuse that to actually distribute code into the XML, a little bit of code into the client, a little bit of data into the client, and a little bit of data into the XML?
Actually, well, this is JavaScript, but we had it this way because we wanted to, everything that's related to, in this case, the pages and the UI, it's in the same place. Both locators and the JavaScript code that needs to be used to handle those elements, it's all in the same place. As for the data, we externalize it completely. So we use data providers to pass the data into test methods
Usually
reading the
we're
XML file.
only doing this for loaded conditions, just to provide a consistency when even before you start interacting with the object, you want to make sure that the page is ready. So just to provide that consistency, and we find doing it this way is more reliable than if you were to hard-code all the conditions in your test case, and something changes again, it's all over the place again. So having it centralized in one place and provide you that consistency actually reduce a lot of the flakiness of the test case. That's what we find. So.
Okay, one last thing before Andrew tears away the mic from me. Actually, it seems to me that you went to great lengths and great difficulty to hide a programming language which is under it. And most of the things that you modeled in XML, and some of the XML files are actually quite complicated declarative programs, could be done easier and more straightforward through an API in Python or Java or whatsoever, without losing the advantages that you just mentioned you're getting through XML. What was the reason to go down this path?
Basically, we wanted to keep everything that's description and or it's a descriptive out of the code. So the code for the test case writer looks cleaner. It's just like the example we showed, search for something and verify the data or the results.
Yeah, the idea is also that we have more technical people working on the application client and the framework, and then have those configurations in place, so that when the test case writer is using it, then he or she doesn't have to worry about those specifics. And also that's why we also try to facilitate the creation of those files, by like the UI map extension and things like that, to make things easier. So yeah, that's another angle we're looking at to improve the this framework to just make this easier task automatically generated. And maybe like a future plugin will be just, once you create a UI map, just create a corresponding data that map to this thing, and then you can just fill out the values and things like that. So
can you give us a quick idea of how big the scripts used to be and how big they are now? Because this thing seems to simplify the script writing, or certainly the end script writing.
Yeah, like we mentioned in the, Google search is a simple example, but then it'll be just calling an application clients method and then just doing some verification after that. If you don't have that, you'll be copy and pasting all those wait for conditions and make sure that even before you can fill it out, the page is loaded, and then like once you hit the submit button, you have to make sure again the result is rendering correctly before you can do asserts. And I mean all those things are like that deals with timing situations.
30%, 20%, 80%.
Yeah, I think more than that, because
a lot more than that.
Yeah, the framework we were using previously, we had to go through all the details.
Especially if you have large forms like a user sign-up form that's like huge, and then you're using it on many test cases.
Yeah, one method.
And then here is just one UI page, and then you probably have a few default data profiles, and then that greatly simplifies the test case because you'll be just calling field form, and you don't even care what it does underneath it. So for those kind of cases, it can reduce by more than 50%.
Yeah.
I mean, it depends on how complex your test case is. Like how many steps and
Thank you.
how big the forms.
Anybody else questions?
There's one there.
So is this going to be available for non-Googlers anytime soon?
I mean, yeah, that's like I mentioned earlier, this is something that we're planning on. So, but in order to do that, we have to make a few changes first, and then, but definitely it's in the plans. So, but yeah, so stay tuned on testing blog.
No date though.
We'll get to it. Yeah, when we're talking about it, and like just we trying to find out what kind of actions we need to take and things like that. So, and then plan it accordingly.
Any more questions?
One more.
Sorry.
Hey. I'm wondering if in the application client, when you have an action, if you encode any assertions within that?
It depends on what kind of action, right?
Yeah.
Sometimes you may, inside the client, you may want to make sure like that, the page is rendering correctly, or like, you may have some wait conditions that kind of indirectly asserts things for you, and then, but then for test case data specific verifications, you do it inside the test case.
And kind of a related question, with the XPaths that you assign to different page element, or I guess UI objects, do you ever kind of encode an implicit assertion in the XPath where the object in question is related to another visible object or some text or something on the page?
Yeah, then you can use a Java. Again, you can extend the UI object to have, in some places we have JavaScript.
We have a special type of UI object, which is a JavaScript UI object, which you just allocate. The locator is actually JavaScript code that's going to be evaluated.
So yeah, that's for something that changes dynamically. So.
Thanks.
Okay.
Okay. So, thank you.
All right, thanks, guys.
Edward.